Hi everybody, today we're going to talk about objective 4.5, which is about identifying trigonometric ratios given the side lengths of right triangles. So we talked about two important vocabulary words the past couple days. We talked about opposite, and we talked about adjacent, and we talked about hypotenuse. All those words are going to come in very handy today, and we're going to have to be able to identify which sides are adjacent or opposite to a given angle. So if I'm looking at the little tiny paragraph below the objective, because all right triangles that share an acute angle are similar, the ratio of the sides of a right triangle don't depend on the size of the right triangle, but only on one of the acute angles. These ratios are known as the trigonometric ratios, or trig ratios, and are defined by the relative position with respect to an angle. Guys, that's just a very, very fancy way of saying that these trigonometric ratios that we're going to learn about today are going to apply to any right triangle. Alright, so don't get too hung up on the fancy wording there. It just again means that all of this that we're going to learn about today will work on any right triangle. So there are three trigonometric ratios. The first one is sine. The sine ratio, abbreviated as SIN. Sine of angle A, if I asked you to find the sine of angle A, that's going to equal the ratio of the leg opposite to A over the hypotenuse. Okay, and again, don't worry about, this is kind of crazy and worded a little funny, but there's a very easy way to remember all of this. So the cosine ratio, or abbreviated cos, COS, cosine of angle A, right here again, is going to equal the leg adjacent to A, remember adjacent means next to, over the hypotenuse, so AB over AC. And then the tangent of A is going to be the leg opposite A over the leg adjacent A. Now again, guys, that is just a very fancy way of saying that when we are given a right triangle, we can use this mnemonic device, SOHCAHTOA, to remember our ratios. So what SOHCAHTOA means is that sine of an angle is going to equal the opposite side over the hypotenuse. So O stands for opposite, H stands for hypotenuse, S stands for sine. Cosine is going to equal adjacent over hypotenuse, and tangent is going to equal opposite over adjacent. So now what does all this mean? Well, you might be thinking, what the heck is going on? But after we do a bunch of examples, I think it'll start to make some sense. So we're just going to jump right on in. So for number one, example number one, for the right triangle shown below, give the correct trigonometric ratio. So A is asking for the sine of R. So what I need to do is find angle R. Sine equals opposite over hypotenuse. So the angle that's opposite angle R is 5. So the sine of R is going to be 5 over the hypotenuse, which is 13. So that's simply all I have to do. I need to find the side opposite angle R. Angle R. And then find the hypotenuse. And my ratio is 5 over 13. Opposite over hypotenuse. Okay? Now cosine of R. Cosine of R is going to equal the adjacent angle over the hypotenuse. So again, this is R. Cosine is adjacent over hypotenuse. The side adjacent to angle R is 12, right? It's not 13 because when we see adjacent, it implies that we're not talking about the hypotenuse. So the cosine of R is going to equal 12 over 13. Okay? And then tangent of R. Tangent equals opposite over adjacent. So the angle opposite angle R is 5. The side opposite angle R is 5. And the side adjacent to R is 12. So the tangent of R is going to equal 5 over 12. Okay? Now let's take a look at angle T, the sine of angle T. Sine is opposite over hypotenuse. So the side that's opposite angle T is 12. And the hypotenuse is 13. So sine of T is going to equal 12 over 13. Sine is opposite over hypotenuse. Cosine of T. Cosine is adjacent over hypotenuse. The side adjacent to T is 5. And the hypotenuse is 13. So we have 5 over 13. And then tangent of T is opposite over adjacent. So opposite is 12, and adjacent is 5. So 12 over 5. So all we're doing here is we're finding the sides that are opposite or adjacent to the given angle. This angle right here where they ask us the sine, the cosine, or the tangent of is called our reference angle. You might hear that word throughout this unit. Alright, and all we have to do is remember SOHCAHTOA to help us remember opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. Okay, so let's take a look at one more, or at a couple more rather. Given right triangle DEF shown, write down each of the following ratios. Do not express as decimals. So again, we just want them as fractions. So again, we're going to have our SOHCAHTOA. Now, letter A is asking us for the sine of D. So sine is represented by opposite over hypotenuse. Opposite over hypotenuse. That's what the mnemonic device means, that opposite over hypotenuse. So the side opposite angle D is 9. So we have 9 over, our hypotenuse is 15. So the sine of D is 15. Letter B, cosine of D. Cosine means adjacent over hypotenuse. The side adjacent to D is 12, and the hypotenuse is 15. So the cosine of D is 12 over 15. Letter C, tangent of D. Tangent means opposite over adjacent. The side opposite D is 9. The side adjacent to D is 12. So our ratio is 9 over 12. You don't need to simplify the fraction. All right, letter D, sine of F. Angle F is given right here. Whoops. Sine is opposite over hypotenuse. The side opposite angle F is 12. The hypotenuse is 15, so we have 12 over 15. Cosine of F. Cosine is adjacent over hypotenuse. Remember, the word adjacent implies we are not talking about the hypotenuse. So the side adjacent to F is 9. The hypotenuse is 15. And then tangent of F, tangent is opposite over adjacent. That's going to be 12 over 9. Now you might be thinking, what the heck does all of this mean? Why do we have to learn this? Well, eventually, we're going to use these to solve for missing angles or missing sides of a right triangle. So it's important that we get really comfortable setting up our ratios. Okay? Number 3, in triangle MNP, angle P is the right angle. So they don't give us a sketch here, so we need to make our own drawing. So they're telling us that angle P is our right angle. And other than that, it really doesn't matter how we label M and N. Okay? If MP equals 24, NP equals 10, and MN equals 26, what is the value of cosine of N? So they're asking us for cosine of N. If I take my SOHCAHTOA, right, we have cosine equals adjacent divided by hypotenuse. So adjacent is going to be 10, right, divided by our hypotenuse 24. Now 10 over 24 isn't an option, right? Wait a minute, 26 is my hypotenuse. I apologize. Right? The side adjacent to N is 10. The hypotenuse is 26. Now 10 over 26 is not an option, but 5 over 13 is. That's 10 over 26 simplified, so we have choice 1. So if the question isn't multiple choice, you don't have to simplify the fraction, but if it is, you might have to. Okay? And last but certainly not least, number 4, in the following diagram of triangle QRS, QR equals 8 and QS equals 17. Determine the value of sine of Q. Okay, so let's take our SOHCAHTOA. Now, sine, the sine function is equal to the opposite over the hypotenuse. So if I'm looking at sine Q, at angle Q here, we don't have the length of the side opposite angle Q. But we can use the Pythagorean theorem here to help us. So let's use the Pythagorean theorem here to help us. A squared plus B squared equals C squared. Okay? We're looking for the leg, the length of a leg, and we're given the hypotenuse. So now we need to find the length of a missing leg. So this is a good review. We have x squared plus 64 equals 17 squared gives us 289. 289. After we get this, we're going to subtract 64 on both sides. These are going to cancel, and then we're going to be left with x squared equals 225. And then remember, when we're left with x squared equals a number, we take the square root of both sides. And the square root of 225 is equal to 15. So now we have all three lengths that we need. Okay? So now we have everything we need to set up the sine of Q. So remember, sine is opposite over hypotenuse. The side opposite Q is 15, and the hypotenuse is 17, so that's our final answer. Sine of Q equals 15 over 17. Now again, guys, this might not make much sense about why we're learning about this, but soon we're going to be given something like this. We're going to be given a triangle, a right triangle, with one angle measurement, let's say that's 30, and one side length, and we're going to be asked to find a missing side length. So here we can't use the Pythagorean theorem, but eventually we're going to learn how do we find missing side lengths using these trig ratios, okay? So this is very important that you try to understand these. All right, so ladies and gentlemen, that's objective 4.5. As always, feel free to reach out with any questions.